Notice I switched things up a little bit on you with the motion of this object because I didn't want you to think that all motion occurs in a horizontal direction. You can have motion in a vertical direction. Here I've got a ball rolling up a ramp, and we're kind of viewing it so that it's kind of going upward. Just so that you don't get too complacent and thinking that objects only move from left to right. They can move from bottom to top if you want them to. So the question is, what would your position versus time graph look like for the motion of this object? Well, what we can first of all do is establish that this is our first dot. And we'll call that, time 0, and we'll let that position be also position 0. So we'll let x, and we'll put it, x sub 0. My initial position is also 0. And then sometime later, and again, it doesn't really matter, this might have been 0.1 seconds. I don't really recall, to be honest with you. All that matters is that these successive dots are spaced in equal amounts of time. And so sometime later, by t1, whatever that, maybe a tenth of a second, it might have been a second, who knows. But the important thing is that my position has changed. In fact, it changed quite dramatically. So again, if I plot my points, at time 0, my position was 0. At time 1, my position changed quite a bit. It might have, again, I don't have a scale written on my graphs here, but it changed quite a bit in that first second, or that first tenth of a second. Notice by the time I get to the second time, yes, my position changed, but it didn't change quite as much as it did in the first time interval. So the second time interval showed less of a change in position. So I might have done something like, I don't know, like this. So notice that there has been a change in my position from time 1 to time 2, but it was not as large as the change in position from time 0 to time 1. And then in a similar way, if I look way up here at the third dot, actually the fourth dot in my progression here, by the time 3, notice that, yes, I have also gotten farther away from where I started. My position has gotten larger and larger, but it didn't get as large as much. So it seems to have done something like this. So notice that instead of having a nice diagonal line showing up on my position versus time graph, what do you see? You see a curve. And we were introduced to this back in Module 1, but that's really important. If you understand that the slope of a line on a position versus time graph is velocity, or average velocity, what we're seeing here is that, yes, we've got a velocity that is changing. My slope is changing. That's what a curve is. A curve is something it's a line that has a constantly changing slope, as opposed to a straight line or a diagonal line, which has the same slope no matter where you're at on the line. In the case of a curve, the slope changes. And in this case, we go from being more steep at the beginning, right? This is a pretty steep section, to being a lot less steep near the end, which means that, yes, my speed or my velocity has been decreasing. My slope is decreasing, and therefore my velocity is decreasing, which is no big surprise when you review the motion. This is a plot of the data from the actual video, and again, it just bears out the point that, yes, when you see accelerated motion, when your object is changing its velocity, you're going to wind up with a curve on the velocity versus time graph. Notice in this particular graph, of course, we were plotting stuff in the y direction rather than the x direction because my object was moving up and down rather than left and right. Okay, so the next challenge that I gave you was to turn your motion diagram into a velocity versus time graph. So actually, let's go ahead and change this this y-axis. I don't want position, I want velocity, right? So I don't know, I'm going to try to write sideways here, velocity. And again, it could be centimeters per second, meters per second. It really doesn't matter. We just want to get the general shape of the sketch. We're not going for huge precision here. Well, one thing you have to ask yourself is at time 0, when we first start caring about this ball, on a velocity versus time graph, we're not saying, hey ball, where are you? We're saying, hey ball, how fast are you going? And in this case, what was the ball doing when it first left the thrower's hand? When it was at the bottom of the ramp? It was going fast, right? It was going, in fact, as fast as it was going to go the entire trip. So this is a key point, is that in this case, at time 0, your velocity is not going to be 0. Right? A lot of us get lazy and we just assume that all graphs start down there at the origin at 0, 0. Not in this case. At time 0, when we first started caring about this ball, it was going fast. It was going with a large positive velocity. In this case, we're calling motion kind of up the screen positive. Then what happened at time 1? Well, it was still going fast, but not quite as fast, right? So it had slowed down a little bit by the time it got to T1. And that first time interval, I'll look at put my T0, when we first started caring about the ball, between time 0 and time 1, the object had slowed down a little bit. It's still got a positive velocity. It's still going up the ramp, but it's not going as fast. And so I'll plot a point there. I get a lower positive velocity. At time 2, same deal. It's still going up the ramp. It's still got a positive velocity, but just not quite as large. And finally, at time 3, again, still going up the ramp, just going slower. So what I wind up with is a dot about there. And what do you notice? Now, on a velocity versus time graph, I wind up with a diagonal line. A diagonal line, which shows me that my velocity is changing, but it turns out that it changes in equal amounts every second. Notice that the vertical distance, the distance in x values from here down to here, is the same as the x value change. So this change in velocity is the same as this change in velocity is the same as this change in velocity. That's really a very important point when we start to formally define what acceleration is. In this case, my velocity has been changing, but it's been changing in equal amounts for equal amounts of time. That's very important to remember. And this is a plot of the actual data from the video. Again, this is a velocity versus time graph, velocity in the y direction, or velocity up the ramp. And what we see is that, yes, indeed, my value started from a large positive value and then decreased. Didn't get negative. It was going up the ramp the entire time, so therefore its motion was always in the positive direction, but it was just getting slower and slower in the positive direction. And essentially this looks like a negatively sloped diagonal line, which is what we expected.